Let's look at some specific models that are used, dynamical models that are applied to tropical cyclone forecasts. These simplified dynamical track models, so-called simplified dynamical track models, do what is called beta and advection. So they take forecasted winds from a dynamical model and they average and they do a quick offline type of calculation that are simple trajectory models, and they only consider the steering by the environmental forecasted winds and the beta effect on the TC motion. So in these models, the tropical cyclone obviously cannot change or have any impact on the environment. It's just being advected by the given forecasted winds, and it can be deep, medium, or shallow. Okay, and these are quick and they can give you an idea of where the cyclone may be headed, and I'm not completely sure whether they are used together with the dynamical models to do iterations or not. But tropical intensity versus tropical environmental steering are related to each other. We are looking here at variation of steering layer with tropical cyclone intensity. This figure is based on results from this paper and some input from the National Hurricane Center, Jim Franklin. So it's looking at tropospheric steering layer in hectopascals going from above the boundary layer to the very high levels. So you can see that as the intensity in hectopascals increases, so the pressure drops, the steering layer is higher. Okay, so it's not monotonic increase, but almost. So you can see when it's a weak storm, and as it gets more intense, the steering layer gets thicker and remains almost the same here. But gets elevated when you reach very strong intensities, because the strongest winds are now above the surface by a lot more, and the interactions with the environmental steering happens to determine these total steering winds, as we said already. Looking at a list of global dynamical models that do track and intensity, we have from European Center. This is the NCEP NOAA Global Forecast System, UK Met Office, and NOGAPS, I think, is the Navy's global model, if I'm not mistaken. It should be, yes. Okay. Is it? Let's say here somewhere. Yes, NOGAPS is the Naval Operational Global Atmospheric Prediction System. So these are the acronyms. These are the scales at which they run. So dynamical numerical models used most often for track forecasting at the National Hurricane Center. A technical summary of these models can be found there. Operational models often used at the Hurricane Center: NCEP GFS, Hurricane Products, UK Met Office model, NOGAPS model, ECMWF model, Canadian Global Environmental Multi-Scale model called GEM. National Weather Services runs the GFDL hurricane model, and the Hurricane Weather Research and Forecasting model. This is a model that is usually used for dynamical downscaling, but there are some enhancements made to make it a hurricane forecasting model. I think GFDL model and the GFS model have very good track records in terms of making successful forecasts, but other models may beat them at times, and the same model may not have the same skill for every cyclone. Depends on many factors, such as how quickly it intensified, whether it's recurving, whether it is touching land, and so on and so forth. Dynamical models apply to tropical cyclone forecasting in different regions. These are operational models used for tropical forecasting in different regions. So here we have either it's a global model or a regional model. So Japan Meteorological Agency, Japan JMA Typhoon Ensemble Prediction System, National Meteorological Center of China, and Australian Bureau of Meteorology, its Tropical Extended Limited Area Prediction System. So you can see that it's a somewhat of an engineering problem, in the sense they find their own optimal configuration for their own region, even though they, for example, you can find ECMWF forecasts for the North Indian Ocean during the cyclone season, and IMD, the India Meteorology Department, makes its own forecasts as well, so people often compare multiple models, but the decision making and the disaster management warning systems, etc., are often relying on one of the models that's used by the operational center that's in charge. Unless it's NCEP, which is running multiple models at the National Hurricane Center. Okay, regional dynamical models, as we said, GFDL, GFDN, and HWRF. So this is the high resolution WRF. I don't know the difference between these, but you can look up. So this is GFDL Hurricane Katrina forecast with observed positions. So it's reinitiated at several times along the way, and this is at the end, and you can see it did make landfall here over New Orleans. There were some confusions about the intensity with which it would hit, but in the end the impacts were much more related to the breaking of the levee that was to hold the waters out and so on. So the intensity didn't matter so much as the amount of rainfall and the failure of some of the systems that were meant to protect against flooding. Okay, but that left a lot of scars in terms of what to do. Here is GFDL's operational grid nests and simulation of a mature hurricane showing the eye-wall rain band structure here, and you can see that the outer domain is at 75 degrees across, and the grid size here is 11 and 5, so the resolutions inside as you go nesting in can be high enough to resolve the core and the core dynamical processes explicitly, which in fact is very important for accurate forecasts. All kinds of simulation and feeding of data from satellites and buoys and sondes and so on happens as well. Simulation of the three-dimensional structure of the core of a mature hurricane is shown here, and you can see how beautifully it is rendered. You can find some really nice animations as well at GFDL's website, which provides amazing animations of the actual simulation. So this is the three-dimensional structure of simulated core of a mature hurricane. Okay. In summary, multi-level regional and global dynamical models are the most skillful models for tropical cyclone track forecasting. Among these models, the GFDL and Global Forecast System at NOAA NCEP have provided the best overall guidance in recent years, but the performance of each model varies significantly from year to year and storm to storm. While it's possible to beat the model from time to time, the model performance for track forecasts has improved significantly over the years, and they are very difficult to beat on a consistent basis. So they have gotten really good. Dynamical models cannot as yet outperform statistical models for intensity forecasting. Dynamical models cannot as yet outperform statistical models for intensity forecasting. Think about that. While neither dynamical nor statistical models can capture rapid intensity changes reliably, which we talked about before, dynamical models, in particular the coupled GFDL model, have shown better if intermittent skill, to the extent that the rapid intensification is very much a dynamic process, a coupled process that depends on ocean warming, not only at sea surface temperature but with depth and so on. And the dynamics of subsidence, warming, convective bursts, and so on. You expect that dynamical processes will help the dynamical model do better in terms of rapid intensification, whereas statistical models based on data may not be able to get enough data to do the rapid intensification, but this has to be watched carefully over the coming years, because as we said already before, forecast skill suffers a lot when rapid intensification is not done properly, and this can cause severe problems for managing the disaster, managing the hurricane, managing the actions like evacuation and preparation for flooding, energy systems, infrastructure, bridges, hospitals, and so on and so forth.